So I'm about to sound really awkward since I didn't hit record at the beginning because I'm going to re-explain everything. You guys pretend to be engaged, okay? All right, so we have this line from last week or from Wednesday, and we're making up 9.65 minutes per mile. And when we plug that in, we ended up with 153.5 beats per minute. Now, you guys, did we need the equation to know what the heart rate at 9.65 beats per minute is? Why not? Because you have a value. It was 152. Now, you guys, on a different day, could I run that exact same pace and have a different pulse rate? Yes. Sure. So this 153.5 is kind of like, it's a prediction for lots of different amounts of runs. Different runs also would still have different pulse rates, okay? So for that particular observation was, how did the model do? Pretty close. Okay, so
the predicted value is close to the C value.
The actual value. Yeah. Okay. And how close? 1.5. Okay. In fact, we could say the model over predicted by 1.5 beats per minute because it was a little bit too big. How are you guys feeling about that idea? And when you guys calculated that 1.5, you calculated a statistical measurement called a residual. Okay? And a residual is essentially the distance between the point and the line. And 9.6. That, you guys, that's this point right here. And that purple distance is 1.5.
Isn't it the point to the left of that?
Oh yeah, you're right. So we're looking at this point, and that's essentially this distance is negative 1.5. Okay, everybody good? All right, so definition of a residual. It's a calculation in which you do the actual minus the predicted.
So the residual would be negative 1.5.
In this case, yeah. And so when the residual is negative, it's because the actual is lower, right? That would suggest that the model over-predicted. We good?
Yeah.
Everybody good? Okay. So if I ask you guys, could you calculate and interpret the residual for a point in which I ran an 8.3 minute mile? No, you guys, I'm not impossible. I would ever in my life make an arithmetic mistake when I'm doing them in my head. And the actual from up top was 166. So the residual is, you do actual minus predicted. So it would be -1. Okay, and we would say the model over or under predicted? Over predicted. By 1 beat per minute.
As much as predicted minus the actual value, but then you get positive one that don't predict. I feel like that would just make more sense.
I understand.
Stats.
Negative, no. I understand what you're saying, and no. Okay. All right, you guys, real quick. Sure. Okay. All right. So here we have something called a residual plot. Okay. And essentially, up here is the scatter plot. The one on top is a scatter plot. The one on the bottom is a residual plot. So if I ask you guys, what's the difference between these two graphs? What would you say?
The residual shows like how much the points deviate from the line of best fit.
Yeah, like both of them, their x-axis is the same. Right? It's just the pace. The y-axis is what's different. Okay, and so I highlighted this point in red. You can see that it has a slightly positive residual, and in fact, that residual is probably about 1. Everybody good? 1 or 2, 1, 1.5, something like that. Okay, and in some respects, you can almost imagine taking that line of fit, and it's all of a sudden become this axis here. Do you guys see what I'm saying here? Okay. And this residual plot is actually one of the more important ways to decide, is a relationship actually linear or not? Okay? Now, what do you guys see in this residual plot?
The 11.83 minute mile.
It's still over to the right a lot, right? And it now has a much lower residual, maybe could jump out at us a little bit, not a ton.
It's sort of like the points are evenly distributed above and below.
Evenly distributed bubble. And in fact, does anybody besides me think this whole graph is a mess? Like, it looks like a random set of points, yeah? All right, now, let's look at a data set that is not linear and kind of get a feel for the residual plot. Cool? Now, you may or may not agree with me about this data set being linear. What do you think? Do you see that it's ambiguous as to whether or not this would be linear? Okay, so let's go ahead and put in a line of fit. Pretty decent line? Okay, so now if we were to sketch that residual plot, we have, say, this point, which would have a pretty large in magnitude positive residual, because it's pretty far above the line, yeah? Okay? What about the next point? Close to the line, but slightly above? Okay? The next ones? Below. On. What do you see here?
It almost like follows a pattern.
I call it curved. Is everybody with me? Okay. Residual plots can tell us when, because like this looks close to linear, right? And if I had not told you I was going to draw a curved set, would you kind of maybe guess that was a linear one? Well, it's either linear or curved at this point. That's all I would expect. Okay? So here's what residual plots do. They magnify any curvature or unusualness in the scatter plot. Is everybody with me? So a model is considered an appropriate model if we have no pattern. That's a pretty big deal. No pattern on the residual plots means appropriate. Patterns are just magnified patterns in the data that. Is that pretty good? It's making sense? Okay. Now, let's pause.